The air feels sharp and dry tonight, doesn't it? As you settle beneath the quiet weight of your blanket, perhaps you feel the earth turning beneath you, a soft, almost imperceptible tilt toward the mystery. We live on a sphere, a pale blue marble suspended in a void so impossibly vast that to simply exist is the greatest statistical anomaly of all. We think we know the night sky, charting the steady paths of planets and the predictable return of comets. We have, over centuries, grown comfortable in our cosmic neighborhood. But what if a stranger arrives, unannounced, and refuses to follow the rules of our polite solar system? Imagine, for a moment, the sheer distance our eyes must travel to find this newcomer. It is an object, designated 3I Atlas, a dense, dark traveler, perhaps the size of a borough like Manhattan Island, silently coasting through the galactic night. This is not a local. This is not a piece of debris chipped from the familiar mountains of Mars or the frozen outer reaches of Pluto. This is an interstellar interloper, and its existence quietly grounds a profound realization. We are not, in fact, an isolated island. We are merely a buoy, bobbing on a wide, flowing, and very busy cosmic ocean. The first impossible whisper came from its trajectory. Why was its path so strangely aligned with the elliptical plane of our planets? The odds of a random interstellar visitor aligning itself so closely are long, akin to finding one particular grain of sand on all the beaches of Earth. Then came the second anomaly. It appeared to lose its signature cometary tail after its closest passage to the Sun on October 29th. A comet without a tail is like a ghost without its shroud, defying the very physics of its classification. A very old object, perhaps 7 billion years in age, might accumulate strange garbage over eons, as Dr. Michio Kaku suggests, leading to an off-scale composition of nickel and iron. But what if this object's behavior is not dictated by 7 billion years of passive history, but by a present, active intent? This is the gentle paradox that keeps a certain kind of scientist awake at night. The kind who understands that the universe often reveals its deepest secrets by first offering us a polite, quiet contradiction. Is this a very old, chemically bizarre rock? Or is it, as Harvard professor Avi Loeb speculates, an engine being revved by something we cannot yet imagine? A probe, perhaps, on a reconnaissance mission, or an artifact designed to test the very limits of our curiosity. We are being studied, gently and from afar, by a visitor whose nature we must discern before the holidays, before its closest approach to Earth on December 19th. This is a story about evidence and echo, about the comforting certainty of gravity and the sublime disquiet of the unknown. As you lie here, listening, where are you in this moment? Leave a comment telling me what time it is and where you are, and let your awareness rest gently on the fact that you, too, are now part of this great, unfolding human reflection. This strange, tailless wanderer, the 3I Atlas, will either reveal itself as a fragmented natural comet or, perhaps, something with very high-speed jets coming out of it. The great silence of space holds the answer, but the quiet tension of waiting is all ours. And yet, even then, this was only the beginning of a much deeper awakening. The awakening, the first act of every great cosmic story, always begins not with a blinding flash, but with a number that doesn't quite fit, a curve on a graph that veers slightly away from the predictable, well-mannered path. For the object, known as 3I Atlas, that number was its trajectory. Imagine standing on a great, invisible clock face, where the planets sweep around the Sun in a nearly flat disk. Astronomers call this the ecliptic plane, a tidy, unwritten highway where all the familiar traffic, Mars, Venus, Jupiter, and our own blue Earth, faithfully adhere to the speed limit and the lanes of Newtonian gravity. The chance of any random interstellar object crossing into our solar system and lining up perfectly with this planetary highway is incredibly remote, a 1 in 500 likelihood, as Professor Avi Loeb calculated. This is the first gentle tug on the thread of our certainty. You and I, as we quietly orbit the Sun, can appreciate the sheer elegance of probability. Our solar system formed from a spinning disk of gas and dust, and so everything in it, from the largest planet to the smallest asteroid, shares that original flat, orbital momentum. When a visitor comes from beyond, from the vast, dark tapestry of the Milky Way, it should arrive like a random arrow, plunging through our system at a steep, chaotic angle, completely unrelated to our local plane of motion. But the 3i Atlas did not. Its approach was aligned, its path almost politely following the main street of our solar system. This is what we mean by a subtle paradox. It looks like a stranger, but it moves with the familiarity of a long-lost cousin. To understand this strange alignment, we must go further back to the initial whisper of its speed. An object that enters our system from elsewhere carries the velocity of its home star and the immense gravitational momentum of the galaxy itself. Its speed, what we call its asymptotic velocity, should be high enough to slingshot around our Sun and escape, forever uncaptured. The 3i Atlas had this necessary speed, confirming its interstellar origin. It was not a comet merely knocked loose from our own distant Oort cloud, the icy shell that surrounds our solar system. It was truly alien, born in the crucible of another star. But even with this certainty, its behavior was unusual. For the object to pass so closely to 3 of our major planets, Mars, Venus, and Jupiter, the timing of its arrival needed to be perfect, coordinated with the position of these worlds in their individual orbits. The likelihood of this, that an object would arrive at the precise moment to achieve such a celestial dance, is even lower, a chance of 1 in 20,000. These are not impossible odds in a universe of infinite possibility, but they are the kind of numbers that encourage an astronomer to put down their coffee cup and look at the screen a little more closely. They suggest, with a quiet firmness, that perhaps this was not a random occurrence, that maybe the universe is not quite as haphazard as we assume. The idea that this object's path might have been chosen, or at least optimized, leads us gently into the domain of conjecture. A natural object, ruled by gravity alone, simply does what gravity commands, its course a cold, mathematical certainty. But a technological object, a spacecraft or a probe, has the luxury of intent. If a theoretical physicist, looking across the vastness of space, wished to send a reconnaissance craft to a solar system, they would likely program it to observe the system's most interesting features. What better way to understand the architecture of a system than to arrange a close flyby of its inner terrestrial worlds, like Mars and Venus, and its grand, turbulent giant, Jupiter? The 3i Atlas, on its voyage, is set to pass very close to Mars on October 3rd, 2025, within a distance of 29 million kilometers. It will then pass by Jupiter on March 16th, 2026. This alignment of celestial timing is why the theoretical physicist, the kind of person who asks the most provocative questions, begins to gently use words like designed or steered Let us slow the pace here and consider the evidence of an ordinary comet, the classic hypothesis favored by many scientists, including the renowned Dr. Michio Kaku. A comet is a chunk of ice and rock, a dirty snowball, as they are famously called, held together by gravity and frozen in time. When a comet approaches the sun, the solar radiation warms it, and the frozen volatiles, the ices of water, carbon dioxide, and methane sublimate, turning directly into gas. This gas and the dust it carries are pushed by the solar wind and radiation pressure into the signature, bright, luminous tail that defines a comet. Dr. Kaku notes that the 3I Atlas is likely a very old object, perhaps 7 billion years in age, much older than the 3 to 4 billion-year-old comets found in our own solar system. In that immense span of time, it would have passed through countless different environments, accumulating a strange, off-spec mix of elements, perhaps explaining its anomalous composition of nickel and iron. This is a crucial point. An old object can behave oddly for entirely natural reasons. Its 7 billion-year history is a diary we cannot read, a history of countless near misses and slow thermal degradation. But the plot thickens around the question of the tail. After the 3I Atlas passed its closest point to the Sun, the perihelion, on October 29th, images captured from observatories in Spain and elsewhere suggested that the object had lost its distinctive cometary tail. If it is a comet, the Sun's heating should have peaked, and the tail should have been at its most brilliant and most extended. The disappearance of the tail, or the lack of any discernible gas emission in the spectrum, leaves a profound silence. If there is no tail, and no clear signs of outgassing the puffing release of gases that accelerates a natural comet slightly, then the object is either depleted of all its volatiles, or it was never a comet in the first place. Imagine the perspective of the Mars Reconnaissance Orbiter, which is currently watching the red planet. On board that orbiter is a powerful camera, the High-Resolution Imaging Science Experiment, or HiRISE, which took a potentially decisive image on October 2nd. That image, capturing the object when it was close to Mars, remains unreleased due to unfortunate, bureaucratic issues. This is where the quiet humor of human systems collides with the cosmic drama. The politics of the day, as Professor Loeb points out, should not sabotage the progress of science. Yet, the finest image we may possess of the 3I Atlas remains in a digital file cabinet, fostering more and more speculation in the quiet absence of data. This waiting, this silence of the HiRISE data, only amplifies the curiosity surrounding the halo seen around the object in other images. This is not the bright, luminous tail trailing behind, but a faint, fuzzy glow in front or all around the object. If this glow is caused by dust particles, the amount of dust is incredibly small, perhaps less than a millimeter thick over a period of 6 months. This suggests a solid, non-vaporizing surface, perhaps just a thin layer of dirt on an otherwise robust, non-cometary body. The observation that the object may be emitting its own light, rather than merely reflecting sunlight, adds another layer of profound strangeness. This leads us to the most provocative thought experiment of all. Could the 3I Atlas be a nuclear-powered alien spacecraft? This is the hypothesis put forward by Professor Loeb, who suggests that the object's lack of a cometary tail, combined with its anomalous trajectory and possible self-emission of light, points not to a rock, but to a machine, especially one designed for interstellar travel, would not rely on the simple sublimation of ice. It might instead use thrusters or some form of advanced propulsion, allowing it to maintain its integrity against the sun's heat and change its course with high-speed jets of gas. These technological jets would require only a small fraction of the total mass of the craft as fuel, allowing the object to achieve high acceleration without losing an extreme amount of mass, an observation that would contradict the natural comet model. The next few weeks, leading up to its closest approach to Earth on December 19th, will be absolutely decisive. Will we see the object fragment into a dozen smaller pieces? The fate of a natural, fragile comet that has been torn apart by the sun's tidal forces? Or will it maintain its integrity, a single, solid object exhibiting those curious, high-speed jets? The answer to that question will either confirm that the Three-Eye Atlas is simply a fascinating celestial phenomenon, a very old, chemically bizarre rock, or it will force us to contemplate an unusual, technological origin. This choice between a rock and an engineered structure is the quiet tension that rides the solar wind toward us right now. The public wants to know the truth, not merely to avoid a public backlash from a false alarm, but because the answer will either confirm our solitary existence or redefine our place in the cosmic hierarchy. The object is going to get as close as 167 million miles away from Earth, far enough that we are not in any immediate danger, but close enough to be viewed by the Hubble and the Webb telescopes, and by hundreds of observatories around the world. We may not be invaded by aliens from a Hollywood movie set, as Dr. Kaku reassures us, but we may already be part of the great, quiet, cosmic experiment. And yet, even then, the evidence deepens with every passing hour. The quietest moments in science often surround the greatest observations the moment an expected feature vanishes, leaving behind a profound question mark. We are moving now into the slow, steady phase of the evidence deepens, where the simple fact of Three-Eye Atlas's existence is scrutinized for its every deviation. We turn our attention away from the object's strange trajectory for a moment and focus on the very definition of its identity, the case of the missing cometary tail. This is where the debate truly sharpens, dividing the conventional wisdom of celestial mechanics from the radical, yet informed, speculation of possible technological intervention. When we look up at a classic comet, that luminous, streaking lantern in the night sky, we are not looking at the solid nucleus itself, but at the enormous volume of material it is shedding. The comet's nucleus, that solid core, is an ancient reservoir of frozen elements, water ice, carbon dioxide, carbon monoxide, and methane. As this nucleus approaches the intense heat of the sun, these ices perform a chemical miracle called sublimation, turning directly from a solid into a gas, bypassing the liquid phase entirely. This released gas forms a vast, diffuse atmosphere around the nucleus called the coma, which can span hundreds of thousands of kilometers, sometimes even larger than the great planet Jupiter. The pressure exerted by the solar wind, the steady stream of charged particles flowing from the sun, and the subtle push of solar radiation then gently sweep this material away from the sun, creating the distinctive two-part tail, one of ionized gas and one of dust. This process is so fundamental, so predictable, that the presence of a tail is the primary identifier of a comet. And yet, after the Three-Eye Atlas passed its closest point to the sun, its perihelion, on October 29th, the visual evidence from Spanish observatories began to whisper of its absence. Where the tail should have been longest and brightest, driven by the maximum solar energy, there was only a puzzling lack of gas and dust. This is the central anomaly that cannot be dismissed with a simple shrug. It demands that we contemplate two opposing, yet equally fascinating, possibilities. First, let us explore the profound depths of time, guided by the measured perspective of Dr. Michio Kaku. He posits that the 3I Atlas is not merely a young, fresh comet from our own Oort cloud, but a deeply, profoundly old object, perhaps 7 billion years in age. Our solar system's materials have had a history of only about 4.5 billion years, making this interstellar visitor a kind of cosmic elder, a witness to the galaxy's formation. Over such an unimaginable span of time, what might happen to a comet? It would have been subjected to eons of solar radiation from countless stars, its outer layers gradually eroded, its most volatile ices baked away in what Dr. Kaku gently refers to as the accumulation of garbage. If a comet has lost all of its most easily vaporized materials, the carbon monoxide and the simple water ice, it would naturally cease to produce a bright, visible tail, even when exposed to intense solar heat. Its remaining composition might be richer in less volatile elements, like silicates or metals. This theory beautifully explains the peculiar presence of nickel and iron content in the object's spectrum, a feature that is off-scale for a typical, pristine comet. What we are seeing, in this view, is the exhausted, dark, metallic husk of a grand old traveler, a kind of cosmic fossil whose interior is so utterly depleted that the sun can no longer coax a luminous spectacle from it. This is the humble, deeply scientific explanation. The object is strange because it is ancient, not because it is artificial. It simply ran out of fuel for its own light show 3 billion years ago, long before it ever encountered our solar system. But the alternative theory, championed by Professor Avi Loeb, interprets the tail's disappearance not as depletion, but as design. If this is an engineered spacecraft designed for the long haul of interstellar travel, it would be built to withstand the very stresses that tear apart a natural comet. Its core would be robust, solid, and non-volatile, allowing it to maintain its structural integrity even through a close solar passage. In this scenario, the absence of the tail is not a sign of exhaustion, but of purposeful containment. Why would an intelligent civilization build a craft that leaves a trail? For deep space reconnaissance, stealth, and integrity would be paramount. Furthermore, Professor Loeb's analysis focused on the observation of at least 7 distinct jets coming from the object after its passage near the Sun. If these were natural outgassing jets from ice pockets, the amount of mass required to generate them and to push them far enough to penetrate the solar wind over 1 million kilometers would imply a comet nucleus at least 20 kilometers in diameter, much larger than initial estimates. This is where the physics strains. The object would have needed to fragment into many pieces to present a total surface area large enough for that much vaporization, yet the object appeared to mostly hold together. The amount of mass that would need to be released by vaporizing volatiles, estimated at 5 billion tons, necessitates an immense surface area that a single, intact object of that size simply cannot provide. However, if those jets are interpreted as technological thrusters, perhaps powered by a nuclear or advanced fusion engine, the physics changes dramatically. Technological thrusters achieve much higher speeds for their exhaust gas compared to the slow, gentle puff of sublimating ice. Because momentum is conserved, high velocity means you need a much smaller mass flux, a small fraction of the spacecraft's total mass, to achieve the same accelerating force. The jets are then explained not as the vaporizing of 5 billion tons of ice, but as the precise expulsion of a small amount of high-speed fuel. allowing the object to correct its course, or indeed, to rev its engine, as the professor humorously suggested. The jets might not be a tail at all, but a demonstration of guidance, perfectly compatible with the highly optimized trajectory that brought it so close to Mars and Jupiter. This could explain the strange glow, the fuzz or halo of scattered light, which might be a small amount of dust pushed forward, or a thin layer of ablation, perhaps less than a millimeter thick over a period of 6 months. This is the gentle balancing act you are invited to perform. Is the nickel-iron content a sign of 7 billion years of cosmic accumulation, or the byproduct of a metallic superstructure engineered for maximum durability? Is the lack of a tail a geological sigh of depletion, or an intentional design choice for stealth? The scientific method demands we assign probabilities, as Dr. Kaku advises, noting that the likelihood of an extraterrestrial nature is non-zero, but very small. Yet, that non-zero possibility is the spark that lights the imagination. We are often prone to assuming that strange behavior must imply advanced technology, when it might simply imply a profound and unexplored history. But history, for the mythic philosopher, is often simply technology we no longer understand. Think of our own history, where ancient civilizations built massive stone circles like Stonehenge. For centuries, we wondered if they were astronomical calculators or religious shrines. The truth, in fact, was a mix of both, a beautiful, primitive technology designed to mark the seasons. Imagine what a civilization billions of years ahead of us might create an artifact that functions both as a deeply ancient piece of interstellar material and an immensely complex technological system. The two concepts might not be mutually exclusive, but rather two sides of a single, slow-turning cosmic coin. The object's path, bringing it close to Earth on December 19th, gives us a chance to resolve this tension. Observatories are scrambling, not just to see the object, but to measure the speed of the jets, the crucial data point that will distinguish between slow, natural outgassing and fast, engineered thrust. Where are you listening from tonight? And what does the sky look like where you are? Take a moment and consider the immense patience required for this kind of astronomical waiting. Our ancestors watched the skies for a few hundred years, but this object has been traveling for billions. The great silence of space demands a slow, careful patience from us, the quiet endurance to follow the evidence, no matter where it leads. The coming weeks will offer a definitive answer. Either the three-eye atlas will shatter, revealing its true, natural, icy heart, or it will hold its shape, confirming its integrity and forcing us to confront the possibility of an intelligence guiding it. The possibility of communication, perhaps some form of mathematical language instead of static on a radio, remains the ultimate smoking gun for Dr. Kaku, the thing that would truly nail the extraordinary claim to the wall. But for now, we are left with the gentle tension of a missing tail, and yet, even then, the echoes from the past were already beginning to shape our future understanding of this visitor. The quietest anxieties of our time are often those that involve the slipperiness of truth, the way information can be manufactured and deployed to mislead the mind. We now move into the segment of echoes from the past, where the mystery of the interstellar object known as Three-Eye Atlas collides with a modern human paradox, the deep fake. This connection between a potential alien technology millions of miles away and a digital ghost of ourselves here on Earth might seem odd, yet it speaks to a shared underlying theme of reconnaissance and the challenge of discerning truth from artifice. Consider the recent experiences of Dr. Michio Kaku, a respected physicist whose expertise on the 3-eye atlas is sought globally. He recounted the strange experience of seeing his own image and voice, digitally manipulated and generated by artificial intelligence, being used on multiple networks to talk nonsense about the very topic he is helping to illuminate. This is the deepfake, a forgery so convincing it threatens to undermine the very concept of reliable testimony. The irony is profound. While one scientist, Professor Avi Loeb, argues that the 3-eye atlas might be an artificial probe sent by an external intelligence to test us, Dr. Kaku is simultaneously battling an internal, artificial intelligence that is using his own identity to confuse the public. The threat, in both cases, comes from an intelligence that is highly advanced and difficult to verify. This gentle, modern anxiety has an echo in the deep past, in the way our ancestors grappled with the unknown. Imagine the mariners of the ancient world, sailing into unmapped oceans. Their maps were often filled with speculation, mythical sea monsters, and islands that vanished upon approach. Their greatest challenge was not just navigating the waves, but navigating the stories. If a traveler returned claiming to have seen a creature that was half lion and half fish, how could the elders discern the truth of the ocean from the exaggerations of a tired mind? They had no scientific satellites, no Hubble or Webb telescopes. They had only testimony and the shaky consensus of the community. In a quiet way, we face a similar problem with the 3-eye atlas. We are trying to determine if it is a natural phenomenon, a cosmic sea serpent of immense age, or a highly advanced, purposeful artifact. When an extraordinary claim is made, like the idea of a nuclear-powered spacecraft, we need extraordinary, verifiable data to back it up, not merely high-resolution imagery that remains locked away in a governmental server. The issue of the unreleased image, taken by the HiRISE camera on the Mars Reconnaissance Orbiter on October 2nd, embodies this clash between necessary secrecy and public demand for truth. While the official argument for withholding the data is tied to political events, the effect is to foster speculation. Dr. Kaku rightfully points out that a single sheet of data is not a top-secret thing that needs to be locked in a safe. It is merely a photograph. The secrecy itself becomes an anomaly, fueling the conspiracy theories and the suspicion that NASA might be hiding something. This human drama, the politician Representative Anna Paulina Luna, writing to the head of NASA, the public yearning for clarity distracts, momentarily, from the object itself. It reminds us that our ability to process the truth is as fragile as the icy core of a pristine comet. We are reminded that our planet, Earth, breathes in a constant stream of external materials. The great challenge is separating the signal from the noise. The 3-eye atlas presents us with 3 distinct anomalies that defy easy classification, each capable of having a natural or an artificial explanation. The first is the trajectory, a path too aligned with the ecliptic plane for pure chance. The second is the chemical composition, the off-scale presence of nickel and iron. The third is the tail's absence, the defiance of cometary physics after solar passage. These 3 anomalies, taken together, form a subtle, yet potent, cosmic triptych. They demand a mythological explanation, just as ancient travelers demanded a story for why the tide went out or why a star suddenly appeared. We might connect this to the ancient Greek myth of the Argo, the ship of the Argonauts. This vessel, built by the demigod Argos, was said to have a piece of wood from the sacred oak of Dodona in its prow, giving it the power of speech and prophecy. The 3-eye atlas, in a modern, technological context, is our own interstellar Argo. Is its anomalous behavior merely the passive noise of its 7 billion-year journey? Or is it, like the sacred wood, a purposeful artifact, whispering a message we cannot yet decipher? Is the nickel-iron content the core of a very old rock, or the metallic hull of a thinking vessel? The anxiety caused by the 3I Atlas and by the deep-fake technology that misrepresents our trusted experts shares a common root: the fear of being misled by a high-level intelligence. The deep-fake of a famous physicist is a technological mimicry designed to look like truth. Could the 3I Atlas, appearing to be a comet, be a kind of cosmic mimicry? Could it be, as Professor Loeb suggested, a probe sent to perform reconnaissance, its current appearance as a depleted comet a form of natural camouflage? If that is the case, the coming weeks are our moment of decisive observation. If the object remains intact, and we measure the speed of its jets to be much higher than the escape velocity of sublimating ice, the technological explanation gains strength. Professor Loeb believes we will know the nature of the object, whether it is a rock or something more exciting, by the middle of December, just before the holidays. This deadline is a quiet cosmic gift for all of us. The promise of resolution. Our hope rests on the data gathered by the hundreds of observatories, including the great space telescopes. The data will either confirm the immense, random, and slow beauty of natural systems, or it will challenge our species to prepare a response. As Professor Loeb pointed out, we may need an international organization to decide how to respond to a visitor entering our cosmic backyard, especially if the intent of that visitor is unknown. We have been put on notice. As we listen to the night, remember the human element in this vast drama. We are the ones who assigned the name 3I Atlas, the ones who debated the possibility of nuclear power or thrusters, the ones who are now navigating the murky waters of digital forgery. The object is a physical mystery. The politics and the deep fakes are a psychological one. Both require us to sharpen our tools of verification and to remain skeptical, yet open to wonder. The challenge is not to panic, but to put all speculation into its proper context, to quantify the probability, whether it is 100% or only 1%. The object itself, meanwhile, continues its silent, relentless approach toward its closest point to Earth. And yet, even then, the cosmic perspective was beginning to unfold, inviting us to view our visitor not as an invasion, but as a lesson in scale. To truly appreciate the nature of the object, 3I Atlas, we must not merely look out, but look back across an abyss of time, so vast it compresses human history into a mere geological blink. We enter the realm of the cosmic perspective, where the scale of 7 billion years, the age Dr. Michio Kaku assigns to this interstellar object, becomes the central character. This is a time frame that dwarfs our civilization and even our planet. The Earth is only about 4.5 billion years old. When the 3I Atlas was already 3/4 of the way through its life, our world was still in the violent, molten process of its own formation. Imagine the universe in the youth of this object. Our sun had not yet fully matured, and the vast, swirling molecular clouds that would eventually coalesce into our familiar planets were still an energetic mess of dust and gas. The 3I Atlas, in that ancient era, was likely orbiting a star that has since died, perhaps even becoming a dim white dwarf or collapsing into a silent neutron star. The object would have been ejected from its home system by some immense gravitational event, a close planetary flyby, or a catastrophic stellar collision. It began its voyage not with an intention, but with an immense, powerful kick, sending it hurtling into the galactic void. For 7 billion years, this body has been alone, sailing through the interstellar medium. This medium is not empty. It is a diffuse ocean of gas, dust, and cosmic rays. As the object traveled, it would have slowly, almost imperceptibly, accumulated material, the fine, dark grains of dust that litter the space between stars, perhaps explaining some of the complex, off-scale chemical signatures, including the traces of nickel and iron. Think of it as a great, dark, cosmic sponge, slowly absorbing the garbage of the galaxy. This view provides a beautifully poetic, natural explanation for the anomalies. The object is chemically strange simply because it has sampled a significant fraction of the Milky Way. This scale of time also speaks directly to the question of the missing tail. A comet's life is finite. Each time it passes close to a star, it loses some of its volatile material. If the 3I Atlas has passed through the planetary systems of 20 or 30 different stars over its 7 billion year lifespan, its outer layers would have been repeatedly baked, evaporated, and sublimated away. The energy required to do this is immense, and the cumulative effect is what we see now, a nucleus so thoroughly depleted of its easily vaporized ices that it is effectively dead as a comet. It is the skeletal remains of a once luminous traveler, now presenting itself to our sun as an inert, dark, Manhattan-sized object. This is the narrative of cosmic decay, a slow, inevitable process that is far more common than the fiery birth of a star. The argument for a technological object, however, also gains a haunting depth when viewed through this same lens of time. If the 3I Atlas is indeed an artifact, then it was built by a civilization that existed billions of years ago. This is a scale of technology and longevity that almost defeats our ability to comprehend. Our own industrial civilization has existed for barely 300 years. If we project our current technological pace forward by even 1,000 years, the resulting technology is almost indistinguishable from magic. What could a civilization accomplish with a lead time of 7 billion years? Their vessels would be built for permanence, designed to survive the deep freeze of interstellar space and the harsh radiation of stellar passes. The debate about whether the jets are natural outgassing or technological thrusters becomes a debate about the patience of design. A natural comet fragments easily under the sun's tidal stress. The very act of its survival points toward unusual resilience. If it were designed, it would be a self-repairing, self-monitoring system, an object capable of maintaining its structural integrity across galactic distances. Its trajectory, so strangely aligned to pass near Mars, Venus, and Jupiter, would not be a short-term guidance problem, but the execution of a 7 billion year flight plan, a celestial algorithm set in motion eons ago. Consider the human reflection in this astronomical mirror. We, too, are driven by an urge to leave artifacts that transcend time. We bury time capsules, carve monuments into mountains, and now send Voyager probes out of our solar system, each carrying a golden record designed to communicate our existence to an unknown, distant future. The Voyager probes are essentially primitive, human versions of the 3I Atlas small, designed for high-speed exit and intended to survive for billions of years, carrying a simple message. The difference, of course, is scale and sophistication. If the 3I Atlas is a technological message, it is a message sent not to us, the current inhabitants of Earth, but to the entire Milky Way, a communication so slow and vast it operates on the timescale of galaxies, not generations. The notion that this object is a probe on a reconnaissance mission gains a subtle humility when we recognize its great age. If it was launched 7 billion years ago, it was certainly not intended to study Homo sapiens, a species that is only about 300,000 years old. It might have been designed to study the formation of planetary systems themselves, to catalogue the raw materials of the galaxy, or to observe the early life cycle of a star, like our own Sun. Its current path, bringing it close to Earth on December 19th, would then be an accidental, yet fascinating, confluence of its ancient programming and our relatively recent emergence. We are not the target. We are merely the unexpected, self-aware microbe that happened to be blooming in the pond when the ancient, silent research vessel drifted past. This perspective should offer a strange kind of calm. We are a recent phenomenon, an emergent curiosity in a cosmos defined by immense duration. When we worry about the potential dangers of the object, Dr. Kaku reminds us that it will get no closer than 167 million miles, a safe, immense distance. We are not going to be invaded. The threat is not physical, it is philosophical. The real danger is the challenge it poses to our understanding of ourselves. If a visitor arrives from a civilization that operated on a 7 billion year timeline, what does that say about the ultimate destiny of our own species? It implies that the human enterprise, if it can survive its own internal conflicts, its politics, its deep fakes, its nuclear fears, might also achieve a kind of quiet, interstellar longevity. Imagine, 1,000 years from now, our descendants viewing the Voyager probe's slow drift into interstellar space. That probe, by then, will be an ancient, depleted, metallic husk, a piece of garbage by the standards of its time, yet revered as a relic. They might ask the same questions. Is this a rock or a technological artifact? The answer will be both. The 3-Eye Atlas presents us with that same complex duality. We must continue to follow the evidence, to measure the exact velocity of its faint jets, to see if it fragments or holds its shape. The answer lies between the cold mathematics of celestial mechanics and the vast, slow patience of a cosmos that operates on a clock we can barely comprehend. The human reflection is all the more vivid for the scale of the mirror, and yet, even then, the great silence was already revealing a pattern. We shift now to the gentle, introspective rhythm of the human reflection, turning our scientific gaze inward to examine how our own species reacts when confronted with the unknown. The 3-Eye Atlas, regardless of whether it is an ancient rock or an ancient machine, has become a cosmic Rorschach test, revealing more about us than it does about the deep space from which it came. The key elements of this human drama are threefold: the demand for disclosure, the difficulty of assigning probability, and the innate human tendency toward both awe and alarm. The demand for disclosure, exemplified by the situation surrounding the unreleased high-rise camera image from the Mars Reconnaissance Orbiter, highlights a profound contemporary anxiety. In an age where digital information flows instantly and globally, the official withholding of data, even if for mundane reasons, like a temporary government shutdown, is interpreted through a lens of suspicion. Dr. Kaku articulated this perfectly. Why preserve secrets when it's merely a photograph? The action is counterproductive, fostering a belief that NASA is hiding something of critical importance. This quiet act of bureaucratic non-release becomes a powerful symbol of the tension between governmental authority and the public's inherent right to know, especially when a global event, like an interstellar visitor, is at hand. This suspicion is rooted in our own long history of myth and cover-up, where the extraordinary is often hidden for the sake of maintaining order. But in this era, the public is not merely demanding information, they are demanding a share in the wonder. The 3i Atlas has been added to the International Asteroid Warning Network, a practical measure that acknowledges its potential threat, however small. Yet, for many, the object is less a threat and more a profound opportunity, an opportunity to finally confirm that we are not alone. The political wrangling over a camera's data file is seen as sabotaging the progress of science, as delaying the moment of collective human revelation. The human reflection here is a mirror of our own digital age. Information is power, and the withholding of that power is immediately suspect. Next, consider the challenge of assigning probability, a purely scientific necessity that runs counter to human psychology. When theoretical physicists like Professor Avi Loeb speculate on a technological origin, they are careful to quantify that speculation, acknowledging that the probability remains non-zero, but very small. This is the language of science, precise, conditional, and proportional. But the human mind, especially when faced with the awe of the cosmos, often converts a 1% chance into a 100% headline. The media, in their necessary brevity, struggle to capture the nuance of very small versus impossible. The idea of a nuclear-powered alien spacecraft is inherently more compelling than the truth of a 7-billion-year-old, depleted, nickel-iron comet. Dr. Kaku's critique of this process is essential. Speculation is fine, but it must be quantified. Otherwise, the public panics, and a false alarm leads to public backlash, causing a loss of trust in both science and authority. The core philosophical danger here is that we confuse possibility with likelihood. Yes, it is possible that an intelligence is guiding the 3i Atlas, the subtle spurt in its velocity around the sun, while not a smoking gun, is one condition that supports the idea of guidance. Yet, that same increase in velocity could be explained by outgassing from a freshly broken piece of the comet, or other entirely natural forces. The human task is to patiently gather enough evidence, such as the exact speed of the jets, to move the probability from the realm of the highly improbable to the realm of the undeniable. Until then, we must resist the emotional gravity of the spectacular explanation. The third element of the human reflection is our tendency toward archetypal patterning, the way we instinctively connect new, mysterious objects to old, mythic stories. The possibility of the mothership separating into a squadron of reconnaissance aircraft, as playfully suggested by a host, speaks to our ingrained cultural narratives of alien encounters. We are, at heart, storytellers, and a tale of a Manhattan-sized object revving its engine and carrying out a hidden intent is simply a better story than a tale of ice depletion and gravitational mechanics. The object's close approach to Earth on December 19th becomes less a celestial alignment and more a narrative deadline, the culmination of the plot. Imagine the quiet, subtle humor in this situation. As Dr. Kaku traveled on an airplane, he overheard people talking about the comet over his shoulder, a testimony to its grip on the global consciousness. The object, millions of miles away, is already a force on human thought, a common topic connecting strangers across continents. This is the positive side of the reflection. The 3i Atlas has become a sudden, unexpected catalyst for collective curiosity and shared wonder. It has forced us to look up, to think about the vast scale of time and space, and to contemplate our place within it. Professor Loeb's call for an international organization to prepare a response to a visitor is the most sober human reflection of all. It acknowledges that the next such object might not be as far away as 167 million miles. It anticipates a future where humanity must act as a single, unified species to address an external challenge. This is the highest form of human organization, the ability to look past immediate political and social differences to address a problem or an opportunity of cosmic proportion. So, as we settle into the deeper calm of the night, ask yourself, what do you want the Three-Eye Atlas to be? Do you crave the quiet, profound comfort of a very old rock, one that confirms the slow, indifferent poetry of natural forces? Or do you seek the exhilarating, terrifying confirmation of a technological probe, one that instantly redefines the human story from a solitary experiment to a small member of a galactic network? The answer reveals your deepest, most private philosophical hopes and fears. The object itself is just a traveler. Its meaning is entirely of our own making. We are waiting for a definitive answer by the holidays, an outcome that will either be a nice gift for all of us, the confirmation of new knowledge, or a slightly more dramatic understatement of the night. This question, the nature of the object, and its relationship to our technological anxieties, must now lead us to examine the very concept of signal versus static in the long history of the universe. And yet, even then, the great silence was already revealing the pattern of the cosmic zoom. We begin the slow, deliberate journey of the cosmic perspective with a thought exercise known as the cosmic zoom. Close your eyes and imagine that you are beginning to pull back from the object Three-Eye Atlas, which we know is potentially the size of Manhattan Island, or about 20 kilometers in diameter if its light is reflected sunlight. As you zoom outward, the object shrinks to a pinprick, then a dust motes, and then vanishes entirely into the vast, indifferent darkness of interstellar space. This act of shrinking the known to the infinitesimal is the first step in appreciating the true mystery of this traveler, the density anomaly. An anomaly, in science, is an observation that deviates from the expected model. For the Three-Eye Atlas, a key anomaly that precedes the missing tail and the strange trajectory is its inferred density. The calculations surrounding its motion, its acceleration, and its stability require us to estimate what it is made of and how tightly packed that material must be. If the object were a typical, fluffy comet, a mixture of ice, dust, and porous rock, it would have a density roughly equivalent to water, or perhaps slightly less. However, the dynamics of the Three-Eye Atlas suggest a far denser composition, one that is consistent with the presence of heavy elements, like the nickel and iron spectroscopically detected by some scientists. This is where the debate between the two schools of thought, the geological, historical, and the technological, artificial, comes into sharp focus. In the geological view, championed by Dr. Michio Kaku, the high density and metallic content are simply the result of 7 billion years of extreme exposure. The repetitive sublimation, the repeated loss of its volatiles during countless stellar passes, would strip away all the low-density materials, leaving behind a hard, concentrated metallic residue or a very dense, carbonaceous core. This depleted state, this core of a primordial comet, would be naturally denser than any younger object in our own solar system. It is a slow, evolutionary process that converts a dirty snowball into a dense, metallic shard. But in the technological view, the high density is a sign of engineering. Professor Avi Loeb's theories imply an artifact built not for natural longevity, but for structural integrity under extreme stress. A spacecraft, particularly one designed for interstellar travel, would be built of highly durable, dense, and metallic materials, to protect its internal systems from cosmic rays, micrometeoroids, and the destructive forces of stellar gravity. The presence of nickel and iron is not an anomaly in this case. It is a signature, the metallic fingerprint of an intelligent design. A nuclear-powered spacecraft would require massive shielding and robust construction, leading to a much higher density than any natural rock formation of comparable size. The density anomaly, therefore, is simply the weight of advanced construction. Let us contemplate the physics of interstellar survival. The great darkness between star systems, the interstellar medium, is unimaginably cold, measured in temperatures just a few degrees above absolute zero. For a natural comet, this cold is a preservative, freezing its structure in time. But for a technological probe, it is a constant stressor, requiring immense energy efficiency and self-maintenance. The idea that this object might be emitting its own light, as some evidence suggests, takes on a new meaning in this context. If the 3-eye atlas is not merely reflecting sunlight, but exhibiting a faint glow of its own, this could be the passive output of an internal power source, a low-level radiation or waste heat from a nuclear engine, designed to keep its internal systems running across billions of years. This is the ultimate expression of silent, cosmic endurance. The cosmic zoom also helps us appreciate the complexity of the ongoing observational effort. We are straining our collective resources, the Hubble and Webb telescopes, the hundreds of ground-based observatories to capture images of an object that is now 167 million miles away. The key is to measure the precise mass flux and velocity of the jets. If the jets are slow, measured in a few kilometers per second, they are the product of gently sublimating ice. If they are fast, measured in tens or hundreds of kilometers per second, they are the signature of a propulsion system. This small difference in velocity, a mere fraction of the object's total speed, is the boundary between the two realities. Imagine the immense digital effort underway to process this data. The scientists, the analysts, are racing against the object's trajectory, hoping to secure a definitive measurement before it passes its closest point to Earth on December 19th and begins its long, silent journey out of our solar system. The political delay in releasing the high-rise data from the Mars Reconnaissance Orbiter becomes even more tragic in this light. That single, high-resolution image, taken on October 2nd, could have offered a decisive view of the object's nucleus, its shape, and its possible fragmentation. The delay is not just a scientific setback, it is a profound human failure to seize a unique cosmic opportunity. The density anomaly is intrinsically linked to the fate of the object. If it is a low-density, fluffy comet, the sun's tidal forces should have already torn it apart, explaining why Professor Loeb's calculations on outgassing mass suggested the object was breaking up into many smaller pieces. The fact that the object appears to be maintaining its integrity, or at least its larger fragments are holding together, points again to a higher density. The ultimate test will occur in the coming weeks. The fragmentation event, or the lack thereof, will be the final piece of evidence that either confirms the great age of the rock or the great resilience of the machine. The fate of the object on its passage near the Sun is the key to unlocking the true meaning of its mass. As you listen, feel the silent weight of the interstellar traveler, this dense object that has survived for 7 billion years. It is a testament to the durability of material, whether natural or artificial. The density anomaly is a quiet invitation to consider what we value most in our own creations: mass, longevity, and structural purpose. We are looking at a system optimized for long-term survival, on a galactic scale, a design brief that transcends all human architecture. We are privileged to witness the end of its first major phase of reconnaissance as it leaves our star. And yet, even then, the next piece of evidence, relating to the mysterious 7 jets, was already being gathered by the great telescopes. The deepest mysteries in the cosmos often manifest not as monolithic structures, but as a pattern, a repeating number, or an array of features that seem to defy randomness. We continue our journey through The Evidence Deepens by examining the most dynamic and perhaps most decisive feature of 3I Atlas, the 7 jets of expelled material observed after its closest solar passage. These jets, visible as streaks of light and gas, are the smoking evidence, the physical signature that demands immediate interpretation. Imagine the nucleus of the 3I Atlas, that Manhattan-sized core, turning slowly against the blackness of space. As the object rounded the sun in late October, observatories noted the emission of at least 7 distinct streams of material. This is not the diffuse, fan-like shape of a typical comet tail, but a collection of focused, energetic outflows. The riddle of these 7 jets is where the entire debate, rock versus craft, will likely be resolved. To understand their nature, we must ask 3 critical questions. How much mass did they carry? How fast were they moving? And why were there 7 of them? Let us first approach this through the lens of traditional cometary physics. If these 7 streams are merely natural outgassing from ice pockets on a comet, they represent the final exhalation of the volatile material that survived the object's 7-billion-year journey. For these jets to be visible and to penetrate the solar wind over a distance of more than 1 million kilometers, they would have had to carry an immense amount of material. Professor Avi Loeb estimated the mass released to be about 5 billion tons of gas and dust. For a natural comet to release this much mass through sublimation, the total surface area exposed to the sun must be enormous, implying that the object would have already fragmented into many pieces, presenting a collective surface area of at least 20 kilometers in diameter. The pressure of the sun's gravity would have pulled these fragments apart, scattering them like beads of glass. This scenario presents an immediate, observational contradiction. While some fragmentation may have occurred, the 3I Atlas has thus far seemed to maintain a level of integrity that is inconsistent with a complete structural disintegration of a porous, icy core. The natural explanation, therefore, requires a series of extraordinary, yet possible, coincidences. A very dense, metal-rich nucleus that happened to crack along 7 perfect lines, allowing a final burst of trapped, residual gas to escape with immense energy. The 7 jets would simply be an arbitrary number, a coincidence of cracks in the material. Now, let us turn to the alternative interpretation that the 7 jets are technological thrusters of an advanced, intelligent design. The number 7 itself has a profound, mythic echo, appearing in almost every ancient culture. The 7 wonders of the world, the 7 days of creation, the 7 planets known to the ancients. If the number is intentional, it could be a simple, elegant piece of design, a redundancy of thrusters for course correction in 3 dimensions, allowing the craft to subtly steer its trajectory around the solar system. The high-speed jets would be the engineered exhaust from a nuclear or high-efficiency fusion engine, precisely controlled to achieve the slight acceleration observed as the object passed the sun. The critical difference here is the velocity. Natural outgassing is slow, technological thrust is fast. If the speed of the exhaust gas is high, measured in the tens or even hundreds of kilometers per second, the mass required to achieve the necessary momentum is drastically reduced. The object would not need to vaporize 5 billion tons of material. It would only need a small fraction of its own mass as high-speed fuel, allowing it to remain intact and solid. This small amount of fuel, contained within a robust, nickel-iron metallic hull, explains why the object has maintained its integrity, why the tail is missing, and why its trajectory is so precise. The 7 jets are then a quiet demonstration of active guidance, a sign that the engine is being revved, as Professor Loeb suggested. The coming weeks, leading up to the closest approach to Earth on December 19th, are the scientific moment of truth. The global observational community, leveraging instruments like the Hubble and Webb telescopes, is currently attempting to gather the data that will measure the speed and density of the jets. If the jets are slow, the object is a comet that fragmented. If the jets are fast, the object is a technological artifact that survived. This measurement is the definitive test, the boundary between the natural and the artificial. The political delay in releasing the high-rise image from October 2nd becomes all the more frustrating, as that data could have helped pinpoint the exact location and size of any potential fragments. Where are you listening from tonight? And what is the temperature like outside your window? Take a moment to consider the sheer complexity of life beyond Earth. If the technological hypothesis is correct, a civilization capable of designing a craft that operates flawlessly for 7 billion years, traversing galactic distances and correcting its course with 7 subtle thrusters, is a civilization that has solved problems we have not yet begun to conceive of. Their control over mass and energy would be complete. The 3I Atlas, in this context, is not a threat, but a lesson, a humble, metallic piece of homework dropped into our solar system, showing us the potential of long-term existence. We must remember the importance of maintaining perspective, as Dr. Kaku advises. Even if the jets are high speed and the object remains intact, the probability of it being an alien craft, while non-zero, is still very small. We are dealing with unknowns, and every unknown must first be approached with the assumption of natural phenomena before we leap to the extraordinary. The cosmos is full of strange physics we do not yet understand. Perhaps there is a way for a 7 billion-year-old, depleted, nickel-iron core to release its final gases in highly collimated, fast-moving jets, without the aid of thrusters. Perhaps the solar wind itself acts as a kind of gravitational nozzle. The ultimate scientific humility is to recognize the limits of our own current knowledge, even as we gather new data. The enigma of the 7 jets is now the central focus of the entire human reflection on the 3I Atlas. The answer will arrive soon, forcing a choice between 2 equally profound realities: the immense, indifferent poetry of time, or the quiet, purposeful ingenuity of a distant intelligence. Either way, our understanding of the universe will expand dramatically, and yet, even then, the next phase of the journey was already underway, seeking the great silence that preceded this cosmic visitor. We begin the movement toward the great silence, the contemplative arc of our narrative, by confronting the ultimate question that the object 3I Atlas raises. Why, if it is a technological artifact, has it maintained such profound silence? For the vast majority of human history, the search for extraterrestrial intelligence has been a search for a signal, a focused radio wave, a mathematical language, a kind of cosmic Morse code. As Dr. Michio Kaku suggested, the 3I Atlas, however, presents itself as an artifact, a physical object that is present, but utterly non-communicative in the traditional sense. The silence of the 3i Atlas speaks volumes. If this is a 7-billion-year-old probe on a reconnaissance mission, why has it not attempted to hail us? Why no beacon, no broadcast, no simple, clear mathematical sequence that would unequivocally announce its presence? This non-communication presents a fascinating problem for the technological hypothesis. We must consider two possible, quiet explanations for this silent transit, both of which humble the human expectation of communication. First, the zoo hypothesis. This theory posits that advanced civilizations understand that newly emergent, less developed societies like ours are best left alone to evolve naturally. The 3i Atlas, in this context, is not a communication device, but a scientific observation platform. Its entire purpose is to maintain stealth and gather data without intervention. Its appearance as a depleted comet, its missing tail, and its robust, metallic core would be the perfect camouflage, a kind of cosmic mimicry designed to be dismissed by an observing species as a natural phenomenon. The silence is not a technical failure, it is an intentional boundary, a quiet professional respect for our developing system. We are being studied, gently, from afar, as if we were a fascinating, volatile biome. The probe is not looking to communicate, it is looking to measure and catalogue our solar system. Second, the deep time protocol. Given the immense age of the object 7 billion years, its mission may have been established so long ago that its operating protocol has no relevance to our current, short-lived civilization. It was not sent to find a species that uses radio waves or digital communication, which are extremely recent developments on the cosmic timeline. It might be programmed to react only to planetary industrial pollution or massive nuclear energy signatures, or perhaps to the construction of a Dyson sphere, megastructures that signify a truly advanced, Type 2 civilization on the Kardashev scale. Our current, noisy civilization might not even register as a signal of interest. The 3i Atlas is simply following an automated flight plan to observe Mars, Venus, and Jupiter, executing a cosmic algorithm that has been running for longer than the Earth has been habitable. Its silence is a profound indifference, not born of malice, but of the simple, colossal difference in our timescales. This leads us to the fundamental challenge of the transit of truth. We are waiting for the object to either fragment or to exhibit high-speed jets before its closest approach on December 19th. The fragmentation, the shattering into smaller pieces, would be the final, clear, visual confirmation of the geological truth. It is a natural, fragile comet, broken by the sun's tidal forces, its complexity merely the result of 7 billion years of accumulation. The human reaction to this outcome would be a mixture of disappointment and relief. Disappointment that the spectacular possibility is closed off, and relief that no immediate philosophical challenge has been presented. However, if the object holds its integrity and the speed of the 7 jets is measured to be much higher than the physics of sublimating ice can allow, the truth of its technological origin will pass through our system with a silent, profound force. The human response to this scientific confirmation would be immediate and transformative. It would force the creation of the international organization Professor Loeb suggested, compelling humanity to act as one species, to address the implications of an intelligence that is orders of magnitude older and more advanced than our own. This silent confirmation would be a philosophical shockwave, altering our search for life, our understanding of physics, and our view of the future. The fact that this debate has been playing out in the public sphere often juxtaposing the calm, statistical probability of Dr. Kaku against the challenging, paradigm-shifting hypotheses of Professor Loeb, is itself a piece of vital human data. It shows that we are ready for the possibility. It shows that our curiosity outweighs our fear. The conversation that Dr. Kaku overheard on the airplane, the global discussion that has made the 3i Atlas a household topic, is a testament to our collective readiness for the extraordinary. We are conducting a massive, passive, psychological experiment on ourselves, testing our capacity to absorb a truth that redefines reality. Where are you listening from tonight? Think about the great silence in your own life, the moments of quiet reflection, where the most profound truths are often revealed. The universe is not shouting, it is merely showing us a single, dense, dark object, asking us to do the work of interpretation. The truth is in the details, the nickel and iron content, the 1 in 20,000 chance of its trajectory, the missing tail, and the high speed of the possible thrusters. The truth is in the unreleased image from the Mars Reconnaissance Orbiter, the data that remains locked away in a governmental file. The greatest echo from the past, in this silent transit, is the knowledge that our own existence is a miracle of improbable complexity. The 3i Atlas, whether rock or craft, is a mirror reflecting that same miracle back to us on a galactic scale. The moment of its closest approach to Earth is rapidly approaching, and with it, the resolution of the central scientific question. We must remain calm, patient, and intensely focused on the final pieces of evidence. The object is a physical event, but the transit of truth is a human one. And yet, even then, the reflection on our own internal, technological progress was already revealing a connection to the cosmic visitor. We now draw a parallel between the vast, silent technology of the distant cosmos and the profound, rapidly emerging technology on our own planet. Our reflection turns to quantum supremacy, the subject of Dr. Michio Kaku's work, and the concept of a computing revolution that will radically change everything, including our ability to understand, and perhaps even replicate, an alien engine. This is where the human future meets the cosmic past. The quantum computer operates on a principle that shatters our current digital reality. Our conventional computers, the ones that manage our daily lives and track the orbit of 3i Atlas, are binary. They compute with zeros and ones, a simple, elegant, but ultimately limited system. The quantum computer, however, computes with any number between 0 and 1. As Dr. Kaku explains, the number of possibilities between 0 and 1 is infinite. This infinite computational space is what gives the quantum computer its immense power, a power that, in a few short years, will be capable of breaking any digital encryption code known to humanity, including the most sensitive nuclear codes. This imminent shift on Earth provides a crucial philosophical lens through which to view the alleged technology of the 3i Atlas. If we, a species only 300,000 years old, are on the verge of a technological leap so profound that it will render all our current systems obsolete, what must a civilization that is 7 billion years old be capable of? Their technology would be so far beyond our nascent quantum systems that it would likely operate on principles we have not yet even begun to hypothesize, perhaps harnessing the energy of zero-point fields or manipulating the fabric of Daylight-Range space-time itself. The theory that the 3i Atlas is a nuclear-powered spacecraft must be understood in this context of advanced physics. A nuclear engine, in the conventional sense, would use fission or fusion to create an immense, steady thrust over immense periods of time, allowing the craft to maintain its integrity and its velocity across galactic distances. The object's survival for 7 billion years, its resilience to the gravitational tug of countless stars, and its highly optimized trajectory all require a kind of internal power and stability that our current technology simply cannot provide. The high density and nickel-iron content, the metallic superstructure of the object, are all consistent with a power system that requires vast, robust shielding. Imagine the sophistication required to design a propulsion system that expresses its exhaust as 7 distinct, high-speed jets. If these are truly thrusters, they are not simple rockets. They are highly efficient, almost invisible systems, capable of making subtle, precise course corrections. They are a form of cosmic steering that uses a minimal amount of fuel to achieve a massive alteration in momentum, the very principle of efficiency that our own engineers strive for. The ability to measure the velocity of these jets in the coming weeks will be a measurement not just of physics, but of the gap between our current technological ceiling and the technological floor of an older civilization. The silent approach of the 3-eye atlas parallels the silent, often invisible, race toward quantum supremacy on Earth. Both represent a monumental, non-communicative force that promises to redefine reality. One is an external visitor that may soon confirm the existence of a superior, ancient technology. The other is an internal revolution that will give us a power that was once confined to the realm of science fiction. The intelligence agencies of Earth, the Central Intelligence Agency, the Federal Bureau of Investigation, and their counterparts around the world are on high alert for the arrival of the quantum computer, not just because it can break codes, but because it represents an existential inflection point for our species. This reflection should provide a sense of profound calm. If we, with our relatively short history, are capable of such rapid, transformative technological leaps, then the universe is likely saturated with highly advanced civilizations. The 3-eye atlas is simply the first piece of physical evidence to confirm a statistical certainty, the inevitability of superior technology in an ancient cosmos. We should not approach this object with fear, but with a scientific, almost religious, sense of humility and awe. The object is far away, 167 million miles distant, and harmless to us physically. It is a lesson delivered to our intellectual doorstep. We are, in essence, preparing to receive a billion-year-old technical manual. The very presence of the object, its strange chemistry, its unique trajectory, and the mystery of its jets are all data points in a technological system far beyond our current comprehension. The final piece of evidence, the fragmentation or the integrity, will tell us whether the artifact is merely a piece of passive, 7 billion-year-old garbage, or a testament to the supreme, active, and enduring power of an alien engine. The outcome, expected by the middle of December, will frame the holidays with either the quiet relief of a geological answer or the exhilarating, daunting complexity of a cosmic one. The universe is full of signals, and sometimes the signal is simply a dense, metallic object passing by in silence, forcing us to ask the right questions about our own technological destiny. Where are you listening from? And what technological mystery keeps you awake at night? The quiet, relentless pace of the 3-eye atlas and the infinite possibilities of the quantum computer are two sides of the same accelerating curve, both whispering of a future that is closer than we imagine. And yet, even then, the cyclical nature of its journey was revealing the ancient pattern of the solar tide. We continue with the cosmic perspective, grounding the technological speculation in the unyielding, deterministic poetry of gravity. Even an object that is 7 billion years old and potentially an advanced nuclear-powered spacecraft must submit to the fundamental forces of the universe. The key force that governs the fate of the 3I Atlas during its solar passage is the tidal force, the differential pull of gravity across the object's physical body. This is the celestial clock that determines whether the object fragments or maintains its integrity. Imagine the object as it rounded the Sun on October 29th. The Sun's gravity, that immense, crushing weight, pulled on the side of the object closest to it, with greater force than on the side farthest away. This difference in gravitational pull, this subtle but relentless stretching, is the tidal force. For a fragile, porous comet, a structure of ice and dust with the density of water, this tidal force acts like a great, invisible hand, gently pulling its structure apart. If the 3I Atlas were indeed a conventional, but merely old, comet, the Sun's gravity would have shattered it into a dozen or more smaller pieces, scattering them along its orbital path. The calculations performed by Professor Avi Loeb and others suggested that for a natural comet to generate the observed 5 billion tons of outflowing material, it must have been in the process of disintegration, providing the immense surface area required for rapid sublimation. The ultimate confirmation of the natural comet hypothesis, the theory favored by Dr. Michio Kaku, would be the final, clear, visual observation of this fragmentation. If, in the coming weeks, telescopes confirm that the object has indeed broken into several pieces, those pieces will drift apart, separated by the gravitational tide. This sight would close the door on the more extraordinary claims, confirming that the 3I Atlas is simply a fascinating, ancient, but purely natural celestial phenomenon, a rock that endured the ages but ultimately failed the Sun's final test. However, the continued observation that the object is maintaining its larger integrity, resisting the Sun's immense stretching force, provides the crucial evidence for the density anomaly and the technological hypothesis. An object that survives the Sun's tidal force must be either exceptionally dense or exceptionally robust. If it is an ancient, depleted comet core, its high density of nickel and iron explains its resilience. It is a solid, metallic chunk of primordial material. But if it is a spacecraft, it means the engineers who designed it 7 billion years ago built it with a structural integrity and material strength far superior to anything we currently possess. Its hull would be an active defense against the forces that govern the natural cosmos. The precise timing of the 3I Atlas's trajectory also speaks to the nature of the celestial clock. Its path is a series of improbable alignments. From its initial alignment with the ecliptic plane, a 1 in 500 chance to its perfect timing to pass close to Mars, Venus, and Jupiter, a 1 in 20,000 chance. This is not the random, chaotic movement of a natural object. It is the perfect execution of a time-based program. If the object is a probe, it is operating on a predetermined schedule, using the gravitational assists of the planets to conserve energy and optimize its reconnaissance path. The cosmic clock for this object is running not on random chance, but on a precise 7 billion year algorithm. Think of the patience required by the theoretical physicist. Professor Loeb, in particular, has been waiting for the final, definitive data points to confirm his hypothesis. The measurements of the 7 jets' velocity are the key. If the jets are slow, the tidal forces are the cause of the object's distress, confirming its natural, fragile nature. If the jets are fast, then the object is actively, technologically, fighting the tidal forces, correcting its course, and maintaining its integrity against the crushing pull of the sun. The human reflection here is one of simple physics, action, reaction, and the patient measurement of both. Where are you listening from tonight? The celestial clock is always ticking, even in the deepest silence of space. The human element in this story, the scientists racing against the object's final transit, the politicians delaying the release of a crucial image from the Mars Reconnaissance Orbiter, is a frantic counterpoint to the slow, majestic pace of the universe. The 3-Eye Atlas will make its closest approach to Earth on December 19th, and by the holidays, the data gathered by the Hubble and Webb telescopes will provide the resolution. This outcome is a gift, regardless of its nature, for it is a gift of new knowledge about our cosmic neighborhood. The tidal forces, the gravitational stress that can tear a planet apart, are the final judge of the 3-Eye Atlas's nature. It will either yield to the power of the sun and scatter its pieces across the solar system, becoming a footnote in cometary history, or it will endure, a dense, silent, metallic structure that proves the immense, enduring power of a 7-billion-year-old intelligence. We must simply wait, calmly and patiently, for the celestial clock to strike its final hour of revelation. And yet, even then, the quiet humor of its appearance, the fuzz and the glow, was revealing a history of ablation. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the 3rd decimal and the 4th significant digit, something snapped. The trajectory of 3-Eye Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3-Eye Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3-Eye Atlas arrived exactly when Mars was positioned for maximum visibility. almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's dynamical systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare. And somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice, Numbers hum the universe's poise. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that. Pa." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image. and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical, the kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from high-rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered. its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random. They're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I Atlas isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics, that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I Atlas is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself, not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names: the immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning. Like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3I Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. It's asking us to listen to what we've become. The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. The long echo continued to hum softly through the centuries. a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the web's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the web's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the web, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, that continuity requires conversation, even with silence. The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. The cosmos, wrote one witness, had finally learned to conduct itself consciously. After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, It wasn't caution. It was choreography. Words on hold. Plans unfold. Silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it, "Not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland, it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, Three-Eye Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist; China, the poker-faced strategist; UAE, the cheerful intern, suddenly told not to speak; and ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did three separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when three space agencies fall silent, the universe keeps talking. The stars don't pause for policy. Three-Eye Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, Coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. We conclude the continuous narrative arc of the 3i Atlas within the rhythm of the great silence, reflecting on the profound human tendency to find meaning in patterns, specifically the archetype of three. Throughout this cosmic journey, the number three has emerged repeatedly, a subtle, mythic thread connecting the science to the human quest for meaning. We have encountered three major anomalies that defy the conventional cometry model: the improbable trajectory, aligned with the ecliptic plane, a 1 in 500 chance; the off-scale composition, the dense, metallic core with unusual nickel and iron content; the missing tail, the defiance of sublimation physics after the sun's close passage. These three anomalies, or contradictions, are the foundation of the scientific debate, forcing the division of the object's nature into three possible realities: the old rock, the new comet, fragmenting, or the ancient technological probe. This is the human mind, seeking order in chaos, applying the fundamental logic of three to an interstellar phenomenon. Furthermore, the technological hypothesis itself is built upon a pattern of threes. The object is programmed to pass close to three major planets: Mars, Venus, and Jupiter, suggesting an observational mission design. The ultimate scientific decision rests on three possible outcomes: fragmentation, slow jets, or fast jets. The final measurement of the 7 jets' velocity will confirm one of these three physical results. The human response required is a unified front from three key entities: the scientific community, the international organization, Professor Loeb suggested, and a unified, trusting public. This gentle repetition of the number three, the rule of three, is not accidental. It is the deep structure of storytelling, a principle that dictates that three events, three characters, or three revelations are the minimum required to establish a meaningful pattern. The universe is not required to follow this rule, but the human mind is required to perceive it. The three-eye atlas, whether rock or craft, has perfectly provided the necessary elements for the most compelling human story: wonder, evidence, and mystery. The quiet humor in this final reflection is the realization that the 7-billion-year-old traveler has no interest in our mythology. Its journey is pure physics, its existence a cold, statistical fact. Yet, our human reflection has woven its anomalies into a timeless narrative, ensuring that its passage through our solar system, even at 167 million miles away, will be remembered for generations. The object's close approach to Earth on December 19th will conclude the gathering of the final, critical data. The final piece of this immense puzzle, the one that truly nails the claim to the wall, remains the one thing we have not yet received: communication. Dr. Kaku's ultimate smoking gun remains the detection of a clear mathematical language. In the absence of that, the entire weight of the technological hypothesis rests on the physical evidence, the metallic density, the structural integrity against the sun's tidal forces, and the high speed of the 7 thrusters. We are asked to accept the possibility of a profound, ancient intelligence that chooses silence over broadcast. Where are you listening from tonight? This deep reflection is an invitation to acknowledge that the pursuit of truth is itself the most noble human gift. The three-eye atlas forced us to look at our own flaws, the deep fakes, the political secrecy, the tendency toward panic, and simultaneously, it forced us to look at our strengths, our curiosity, our ability to cooperate across nations, and our enduring faith in the power of mathematics and physics. The great silence is not empty. It is filled with the faint light of a 7-billion-year-old artifact, or rock, and the immense, collective sound of human thought. The final thought that loops back upon itself is this: we may have been searching for a loud, clear signal for decades, when the truth was always much more subtle. The universe often reveals its deepest secrets by merely passing by in the dark and forcing us to do the quiet, meticulous work of observation. We may already be part of the experiment. The question of the three-eye atlas's nature is about to be answered, and the only remaining task is to be grateful for the question, and so we bring our quiet journey to its close, leaving the three-eye atlas on its long, final trajectory out of our solar system. The enduring human journey is one of patient inquiry, a gentle, cosmic scavenger hunt that sees wonders in the debris of time. We have followed the evidence, from the 1 in 20,000 trajectory to the missing tail and the riddle of the 7 jets. We honor the quiet endurance of our species, the small, fragile civilization on a blue marble, whose ancestors survived soup that might kill you, and whose descendants are now ready to contemplate 7-billion-year-old technology. Whatever the final measurement reveals a natural rock that shattered, or a metallic probe that silently endured, the gift is the same. It is the expansion of human knowledge, the gentle reminder that the universe is vast and we are small, but our capacity for wonder is not. We thank the patient work of the scientists, the astronomers, and the philosophers who stayed awake so that we might rest. The great mystery passes now, leaving us with a profound, quiet sense of scale. Sleep well, and know that history bends, but never breaks. The light from the next cosmic visitor is already on its way.